Hello students, welcome. In this video, we will discuss equipotential surfaces and their important properties. So first of all, what is equipotential surface? So let us go with the definition. Any surface over which potential is same or constant is called equipotential surface. They should be clear from the name itself. Equipotential. Equi mean equal, potential mean potential. So mean the surface over which the potential is constant is called as the equipotential surface. Now let us discuss it in detail, how these surfaces are formed, how the potential become equal. So if you have a positive charge here, you know this positive charge will have a potential in this field, in its field, or let it be point be P. So at point P, the potential due to this positive charge is 1 upon 4 pi epsilon 0 q upon distance between the observation source and observation point. So let it be R. We know it. We have discussed this formula, derived this in the earlier videos. So you can see there, potential due to a charge at a point is given by this relation. Now see here, q is constant, yani magnitude of charge is constant. 1 upon 4 pi epsilon 0, that is also constant. Its value is 9 into 10 to 9, but is left only R, mean the distance between the source and observation point. If this distance is constant, I means to say, if R is constant, B will be constant. Now what it means? If you take points like they are at a same distance R, same one here, R, 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 R. So now all these points are lies at a same distance. So as all these points are lying at a same distance, it means the potential at all these points will be equal, right? So these points are called as equipotential points. Equipotential points. So equipotential points क्या होंगे? How can we define it? The points in the electric field, the points in the electric field where electric potential is same is called equipotential points, right? So now if you join all these points, right? So join all these points in this way, like a circle. Circle has the same radius, right? So now all the points over this diameter of circle, right, all will lie on the same potential, because their distance from the source charge will always remain same, that is R. So now if all these points are lie at the surface, if all these points lies at surface, all these points lies at surface, then it is called equipotential surface. Equipotential surface. So in this way, the shape of equipotential surface for the charge, single charge is spherical. So it should be kept in mind. The shape of equipotential surface for a point charge will be spherical in nature. If you have uniform electric field, the field whose strength does not vary, always represented by parallel lines. So in this case, the shape of the equipotential surface will be a plane perpendicular to x-axis. So these are the two surfaces where potential will be constant. V1 means at each point over this surface the potential will be V1. Suppose 5 volt. So if you take anywhere, any points, the potential will be 5 volt. Second surface in which potential is V2, right? So here if the potential is 4 volt, so same way at each and every point the potential will be 4 volt. So in the examination point of view, it should be kept in mind for a point charge, the shape of equipotential surface is spherical, and in case of uniform electric field, they are perpendicular. They are the planes perpendicular to x-axis. You can define it. You can draw it also. Now, some important properties are there. First one, that is a very important. No work is done to move a charge over equipotential surface. So आप समझ गए होंगे. नो वर्क इज डन टू मूव अ चार्ज ओवर इक्विपोटेंशियल सरफेस, यानी अगर हम चार्ज को इक्विपोटेंशियल सरफेस पे मूव करेंगे तो जो वर्क डन होगा वो जीरो होगा. सो हाउ एंड व्हाई? सो लेट अस प्रूव इट. Let us suppose it is a positive charge and we are having here, this one is the electric potential, equipotential surface around it. Take 2 points here. Let this point be A and this point be B, right? So now suppose you are moving a charge from point A to B. Let we are moving a charge from point A to B over equipotential surface. So then work done. So work done क्या होगा? Work done is, we had discussed in the earlier videos, it is the product of charge into potential difference, VAB, Q into VAB. VAB means the difference in the potentials between these 2 points A and B, Q into VV minus VA. This is the work done. Now you know, but we discuss here, कि over the equipotential surface, the potential at each and every point will be same. Means to say, if potential at point A is 5 volt, potential at point B will also be 5 volt, right? So potential is constant over both these points, means VA equal to VB. Potential is same over the surface. So you know, if potential is 5, so 5 minus 5, 0, right? So work done is Q into 0 over 0. So this is how to prove work done to move a charge over equipotential surface is 0. Now Second one, the important property, electric field is always normal to equipotential surface. So electric field is always normal or perpendicular to equipotential surface. So we can also prove it. So we know work done to move the charge over equipotential surface is 0. Work done is 0. Now what is work done? Work done, you know, it is the dot product of force into displacement. That is F dot ds is 0. Now what is force? Force, you know, from the electric field, that is what? Force per unit test charge. So F equal to what? Q naught E. So put the value of F. Q naught E dot ds equal to 0. Now to satisfy this equation, suppose suppose Q naught is not equal to 0. There is no need to suppose also, because charge cannot be 0. Magnitude of charge cannot be 0. It means what should be there? It means the product E dot ds is equal to 0. But how it can be 0? So it means E ds cos of theta equal to 0. Now how this equation can be equal to 0? If charge is there, electric field can never be 0, right? Surface cannot be 0. It means theta is somewhat like this, so that whole of the equation is 0. It means theta should be equal to 90 degree, because cos 90 0, right? So it means E ds cos of 90 here was 0, so 0 equal to 0. So in that way equation is satisfied. It means electric field is perpendicular to surface. And last one property, two equipotential surfaces never intersect. Two equipotential surfaces never intersect. So see here, two equipotential surfaces never intersect. But how? So let us discuss. Suppose this is our positive charge here, and this is the equipotential surface around it, right? So this is the equipotential surface. You know, the potential at each and every point over the surface will be constant, and let it be 5 volt. And there is another surface around it like this one, and suppose the potential over this surface is 4 volt. So now you see, if this surface has the 5 volt potential and this surface has the 4 volt potential, if they intersect like this one and this one, if they intersect, it means at this point, at the point of intersection, there is two values of the potential. There are two values of potential, right? Now you know, equipotential surface is a surface where potential is constant. It cannot have two values, right? So it means equipotential surfaces never intersect. So you should write the answer like this. If two equipotential surfaces intersect, there will be two values of electric potential which is not possible, right? Hence, two equipotential surfaces never intersect. So dear students, thank you very much. In the next video, we will discuss some other topics. So please like and share the video. If you have not subscribed the channel, so you should subscribe this. Thank you very much.